Alright, so here's chapter 23. Most of this is really definitions, really what weather is, what climate is. Alright, so let's move through this. So the main thing here is that the sun, the solar radiation, is what causes the weather to change, and this obviously profoundly affects the atmosphere, we have this thing called a hydrologic cycle, which is of course sometimes called the water cycle, where the water evaporates from the oceans primarily. Of course, this happens on a much smaller scale in lakes and rivers. Anyhow, from the oceans, the water evaporates, it rises into the atmosphere, then if conditions are just right, the water vapor will condense into liquid, and that's when you have clouds forming. And of course, when conditions are right again, then you'll have rain, and so this returns some of the water, not 100%, back into the oceans. We'll talk a little bit about that in a moment. Let's talk about the cloud formation processes, and so this is where alright, so this is where, as it says here, clouds form when air masses are cooled to their dew point. So let's talk just briefly about dew point, which I already have in another window. So what is the dew point and the dew point temperature? So it's the temperature, as it says here, at which the air can't contain all the water vapor. And so what happens at that point is the water vapor will condense, right, which is, of course, the process where a vapor goes back into a liquid. The dew point is always equal to, or lower than, usually lower than, if it's not raining, or equal to the air temperature. Okay, if the air temperature cools to the dew point, or conversely the dew point rises to equal the air temperature, then this is when you have fog or dew, obviously dew on the ground, but which, by the way, of course, dew is not precipitation, right? That's something that happens locally at the ground level. Or what we're really talking about as far as weather, you have clouds forming. That's the main thing. At that point, the dew point temperature is equal to the air temperature, and that's when the relative humidity is 100%. Okay. Remember, this can happen way up in the atmosphere, and be where the dew point and the dew point temperature and the air temperature are equal to each other, and not be the same. Not be. It would be different, for example, on the ground. All right, let's go back to our slides. Okay, so a big idea is convection, right? I just want to remind you, convection is when hot air physically, or hot material, it doesn't have to be air, but when hot material physically moves from one location to another due to a difference in temperature. Let's see, this is, I think we covered that already. Alright. Let's see, I seem to be going backwards. Alright, so this is the thing that they like to talk about is a parcel of air. That is an air mass, basically, that has the same conditions, the same temperature and similar pressures and so forth. And what happens is the air mass moves as one. It doesn't like to separate and become part of the rest of the atmosphere. I mean, eventually it does, but for when the particle is first formed, it'll move as one. That's the main idea here. Okay, so obviously hot air also hot air rises, and then when it rises, it also cools off, and that cooling process can cause obviously the dew point to be reached, and then you get condensation. And the condensation needs to have nuclei. If the nuclei are not there, as it says here, you get what's called supersaturated air. We don't really need to go into that any further. All right, so this is when obviously you have clouds forming. All right, so precipitation. Let's see. So this, of course, precipitation is when the actual liquid returns to the Earth's surface. Notice it says here, as I said earlier, dew point. The dew and frost are surface processes. They don't come from the atmosphere. They happen right at the surface. Let's see. I think that's good enough for that. This is just a discussion of weather patterns. This is not exactly what happens, but it's pretty close, where you have in the around the equator, you have really hot regions on the Earth that pretty much stay hot year round, and you have the hot air rising, and then so that's around anywhere from 10 degrees north of the equator to 10 degrees south of the equator, and then that hot air rises and then drops, cools, and this is an overall effect, and it cools and drops around latitudes plus or minus 30 degrees. Okay, so you have low pressure near the equators and bands of high pressure at roughly 30 degrees north to 30 degrees south. Okay, so these are the different air masses. All right, so you can see there's these different regions, the continental polar region here, maritime polar up here and over here, and the continental tropical right here, and maritime tropical down here and down here as well. There's just focusing, of course, on North America. So these things tend to dictate, as it says, the overall weather conditions over over a few days generally, and I mean that generally, obviously, that can change weather can change very rapidly, but these overall air masses tend to affect the weather and changes in the weather. Okay, let's see. We're going to skip this and this. Okay, so some of this stuff we're going to just kind of glaze over. Let's see. There's three major types of storms, as you probably know. Thunderstorms, tornadoes, which of course tornadoes have the highest wind, but they're relatively small in scope, and then of course hurricanes, which are really large, hundreds of miles sometimes, and can affect huge areas. Let's see, we're gonna skip this. Okay, so we'll talk about weather forecasting. You really, in modern times, we have, of course, supercomputers that are constantly running, and they're trying to predict the weather. The weather is inherently unpredictable, of course, because you have small influences that really just you can't really take into account when you do your modeling. Little tiny things can affect the overall outcome in a large sense. That you just, like I said, you just don't know. Sometimes that's, by the way, sometimes that's called the butterfly effect. A butterfly flapping its wings in China, as they say, can affect the weather in the United States. Obviously, that's a kind of a just an interesting point of view. But overall, it's true that you with just minor fluctuations that your equations never took into account. And the thing is, the overall thing about this is your equations can't take everything into account. There are little variations that happen that you just can't account for, and that's the overall idea of that's actually the weather forecasting is what brought about the branch of physics called chaos theory. Anyhow, enough of that. So with the modern calculations, we can go usually about 3 days into the future, and of course that's subject to lots of error at times. All right, and even with more calculations, we might get a few more days out of this. But again, the further you go into the future, the less certain you are. Let's talk a little bit about climate. So it's an average of what's going on with the weather. The climate is, you're looking at many years, and asking yourself what happens. And what are these predicted patterns of the weather? Obviously things like it's hot in the summer in North America, in the months of June, July, and August. That obviously is it would be climate. All right, let's move on. Of course, there are many factors, but the main thing is the intensity of the sunlight. Of course, the Earth is tilted by 23.5 degrees, and that tilt stays at the same orientation around, year round, as the Earth goes all the way around the sun. And so, during what we call the summer months, it's of course winter in the southern hemisphere, and of course this varying amount of sunlight affects the number of hours of daytime. All right, so this is a nice picture of it, just showing in the these, what they call the low latitudes. Near the equator, you're getting more or less the same amount of sunlight. And then you have the mid latitudes where we live, and then the high latitudes, closer to the poles. There are obviously these climate zones. There's tropical, the polar climate zone, and the temperate. The temperate is kind of where we live. All right, let's move on. Skipping some of this stuff. The water, obviously, the temperature of the water greatly affects the weather and the climate. All right. I wanted to get to climate change. So this is a big topic that's always up for discussion, and I'll cover this in the next video. I'm running out of time.